Hi, everyone. Good morning, everyone. We are here for our last webinar of the Emeralds project. The title is Final Outcomes and Best Practices in the Mobility Ecosystem. We are all here to, let's say, talk about the results of the project and what we've done along these 3 years of very good work that we performed with our in our consortium with our partners. And we have today 3 panelists from the project. So we start with the final technical outcomes and lessons learned by Yannis Theodoridis, project technical coordinator of the Emeralds project from the University of Piraeus, Greece. So welcome everyone. The webinar will be recorded and will be available for the audience after the webinar itself on our website and on our social media channels. I leave the floor to Yannis to introduce himself and to talk and present his work. The floor is yours, Yannis.
Thank you, Maria Letizia. Also, good morning from my side, and thank you for joining us today, which is actually our final event within the duration of the project. Let me share my screen. I guess I've made it.
Yeah, perfect.
Okay, good. Thank you. So we are going to discuss about the Emeralds technical outcomes as an introduction, more or less, of what will follow by the other speakers of today. Very, very briefly, perhaps most of you have already knowledge about the project, but just to recap, we are talking about research and innovation action of the 2022 data call. It started January 23 and it ends December 25 in 2 weeks, actually. And it is about the urban data focused mobility analytics as a service, which is very important nowadays since urban mobility data is out there, and we have all the challenges for efficient processing and analytics, especially with machine learning, deep learning, and AI models. So before I'm going to the more technical details, very, very quick look of the consortium. We had a nice mix, I think, of SMEs, industries, universities, and research organizations from 10 countries, if I'm not wrong, from Europe, coordinated by Ilecom Greece. So back to the technical discussion. What was our vision, our goal? To develop a mobility analytics as a service toolset consisting of a set of services. We call them Emeralds in our go in the project, which would be able to collect spatio-temporal mobility data, to process and analyze this data from the edge to the cloud. So computing continuum was a very important aspect of the project. For sure, to visualize both the data and the analytics results in dashboards, and in parallel, having all the privacy awareness that this data deserve. And of course, the stakeholders are the public authorities, mobility SMEs, integrators, technology providers, and so on and so forth. Why urban mobility data? Because it is for sure that we have all these dimensions that are challenging for research in research innovation action in a data EU project. We have the volume, for sure. We have plenty of data generated every day. We have the velocity. We talk about streaming data, so very fast, continuous actual evolution of the data. We have the variety from the expected GPS. From the expected GPS data, but also semi-structured data like schedules, or even structured data like posts. We have complex information, traffic patterns, different behaviors that we have to analyze. We have sensitive data, for sure, since we are talking about mobility of humans. And also, last but not least, we have heterogeneous data, since they come, for instance, for different devices. All this, let's say, collection of data is the baseline, our starting point for the research and development we've done during the project. And what were the challenges? The challenges were driven, as in every EU project, not only by the state of the art in the research of the field, but also by the use cases themselves. So in this project, we had 3 use cases, 3 different cities, geographical areas. First use case is in The Hague, in Netherlands, where the target there is to improve the safety and security measures during events. And how, for instance, to make a better crowd management and to ensure that the risk measures you have in mind will be developed and achieved. The second use case is in the Rotterdam, again, Netherlands, but a different domain. Here in Rotterdam, we have the traffic flow in the highways, in the roads of Rotterdam, and the goal is to reduce the congestion and improve the traffic flow. Let's say, having in mind, or having as a goal what we call a forecast as a service environment. And the third use case is in Riga, where now we move to the public transportation, and we aim to have efficient public transport services with optimized routes and schedules. In order to achieve all these, let's say, goals and reach the outcomes that would address the use case needs, we have designed an architecture. Here it is the reference architecture, a very high level. Of course, there are many technical details within each component that we don't have the time to present today. Starting from the left, where we have bottom left, we have the in situ data harvesting. So we are working at the IoT level, and we have edge processing. Moving to the data analytics, since we collected the data, we have different models and methods, either centralized or federated, or even active learning from the edge to the cloud. So we have edge, let's say, based analytics, but also cloud-based analytics. And all these are integrated in a so-called mobility AI as a service platform, which will actually be one of the talks that will follow my introduction. All this architecture is assisted by a security data governance layer, since security and privacy awareness is a must in this project, and by a layer on visual analytics and dashboards, which will support the decision making. During these 3 years, we developed a number, I would say 30 to 40, if I'm not wrong, models, methods, services, tools from TRLs ranging to 4 to 7, from 4 to 7, which means high TRL for research and innovation action. Just as a bullet, we have two groups of services. The first group had to do with data processing and analytics, and the second group had to do with the data infrastructure and development tools and platforms. In the first group, these are the ones that are presented are families of services. Below each title, we have several services. In situ, processing and analytics, as I mentioned earlier, traffic monitoring, interpolation, data analytics on a trajectory level, active learning, explainable AI on mobility data, and at the data infrastructure and development group of developments, we have this mobility AI as a service platform, the mobility analytics dashboard, the security backbone. Some of these will be presented in the following. Just to summarize, because actually my presentation served more or less as an introduction rather than to the in-depth presentation of what has been done in the project. Our work that finishes in 2 weeks, as I said earlier, went into the very depth of the mobility data analytics. We feel that we have advanced the state of the art, and this is proven, if I can say this, by the high number of publications we have already achieved. If you are interested in our website, we have all our publications listed. Of course, we also have some details, some newsletters presenting details of the services, and we will also have the public deliverables when we get the green light from the community. Thank you for the time. At the moment, of course, we'll be around, and we will have the opportunity in the Q&A session to discuss more if you need extra details on this. That's for the moment from my side. Maria Letizia, please.
Yes, thank you very much, Yanis. Very interesting, and also about the last part, I will get back to this later on, but obviously it's an important part because we are closing our project in 2 weeks, but the work done is not closed. So despite this, we are working hard on other part of and some let's say legacy for the project that are important. So now, for the moment, I go to give the floor. I'm going to give the floor to the next speaker. So we have with us José Luis Carcel from Atos. He is going to present the final outcomes and best practices from his point of view on the platform. So I give the floor to you. You can introduce yourself and present your part of the work done. Thank you for being here.
Okay, thank you, Maria Letizia. Good morning, all. My name is José Luis Carcel from Eviden, part of the Atos group. And today I will introduce as final outcome the Emerald Mobility as a Service platform that Atos has developed in the Emerald Web. So the main objective of the presentation is first to introduce the concept of the Emerald Mobility as a Service platform. We will disseminate the platform architecture and the different modules that compose it. And finally, we will also showcase how the platform works, how it operates to put in production a crowd density Emerald model that has been developed in the context of the project by AIT, one of the partners of the consortium. So focusing first on the concept of the Emerald Mobility as a Service platform, the main objective of this platform in the project is to manage the lifecycle of machine learning models supporting the design, the training, and the deployment stages of these models, and also offering the cloud edge inferencing and the model offloading capabilities that are needed to run these models in the use cases infrastructure for the project. The platform has been built on top of four main design principles. First of all, it relies on the concepts of containerization and orchestration using Docker and Kubernetes to orchestrate these containers. Then it's also an open source solution that relies on Kubeflow for orchestrating AI/ML pipelines that will be run leveraging the Kubernetes infrastructure. The third principle is about the CI/CD and the as a service capabilities that will be exploited by using GitHub Actions and Kserve, two important tools to build the platform. And finally, it will also offer continuous monitoring and logging by leveraging solutions and tools like Prometheus, Evidently AI, and Grafana. This is the platform architecture, and we always say that the platform is built by gluing or by putting together four main modules. So the first module that composes the architecture is the data management that is used to store the different data sets that will be used to train the machine learning models. It works as a data storage and repository. It's built mainly on top of two main solutions, which are MinIO and MobilityDB, two database solutions that allow us to store data in a CSV JSON file format, but also in a relational way. And in the data management module, we allow the machine learning developers and other modules of the Emeralds architecture, like injectors and orchestrators developed in the Web Package Tree, to ingest the different data sets using the MinIO user interface, also the MobilityDB client, and the MinIO APIs, among other ways. So once we have the data stored in our data management module, we can jump to the second block of our architecture, that is the machine learning model development, that allow us to design and train the machine learning models and also do some evaluation and experimentation of these models. The model development is mainly done in the Jupyter Notebook solution that is embedded within Kubeflow, which is the main platform that we are using for this part. And with the Jupyter Notebooks, we will be able to design and train these models. And then with Kubeflow pipelines, we will be able to automate the model training and push the models that are trained to a model repository that in our case will be, again, based on MinIO. Within this block, we also have a second part that is on the evaluation and experimentation of models, where we have relied on MLflow. Once we train the machine learning model, the third block relies on GitHub for working as a model deployment stage. So we will deploy the models on the GitHub repositories. Mainly, we have three main different repositories per Emerald. One is used as a sandbox, and the two main repositories are focusing on the staging and the production environments. So first, we will deploy the models on the staging environment. And once these models are deployed in the staging, we will migrate them to the production environment. This migration and deployment is performed relying on the GitHub actions and GitHub pull requests. So a pull request triggers the migration from the sandbox to the staging, and another pull request will trigger the migration from the staging to the production environment. In both staging and production environments, we have the capabilities to serve this model as a service with API REST, where we will be able to query and to perform inferences to these models in both the staging and the production by specifying some endpoints that will be enabled by using the Kserve library. Once the models are served and deployed and we can perform inferences, we will have a final module of model monitoring that also will allow us to track the status of the underlying computing infrastructure where the platform is run, and also to test the model performance. For this, we will rely on different tools like Prometheus and Grafana Loki for gathering the logging, Evidently AI for getting the data related to the model performance, and Grafana to create dashboards, visual dashboards that will allow us to visualize the metrics that we gather from both the models and infrastructure. Having said that, with this architecture, we have been able in Emeralds to deliver different services. This is the set of services or Emeralds that we have produced in the project with the collaboration of other partners in the consortium. And as you see, we have different services for parking estimation, crowd density, trip training, share mobility, predicting the zone entries and exits, and the traffic state forecasting. And in particular, in this demonstration for this video, what we have prepared now is a crowd density demo, where we showcase how the mobility as a service platform puts in production the crowd density Emerald model as a service. This crowd density model has been developed by AIT, and the main objective is to forecast the crowd density patterns and evaluate the effectiveness of the crowd management systems that AIT has developed. So now, as I said before, I have a video where I will showcase the platform operation, and I will go through the different modules so you can see how the platform works and operates. Let me start the video. So first, for the data management, as I said, we will rely on Min.io for storing the different data sets. Here, the user can authenticate using Keycloak, and we can see that the user have a public bucket and a private bucket for storing the different data sets. This is an example of some of the data sets that have been used for training the crowd density Emerald service. Okay, so here you see that the different files can be uploaded in different formats like CSV and so on. So once the data is stored there, we start with the model development. We access to Qflow, and inside Qflow we can have different Jupyter notebooks where the data scientists and AI engineers can train the model. So this is the notebook that AIT has used for training the crowd density Emerald. And we see that in the notebook, the AI engineers can define different stages for the functions, the metadata. They read the data from the Min.io buckets where we have stored the data sets. Then they can also perform some preprocessing. And finally, they have also stages for training the models. So once the models have been trained, they can be pushed either manually or automatically using Qflow pipelines to a model repository. Here we're showing examples of pipelines, and this is an example of the model repository that, as I said before, is based on Min.io, and where we store the crowd density Emerald model, the pickle that has been generated in the Jupyter notebook. Once the model is trained, we deploy it in the model deployment environment based on GitHub. As I said before, we have 3 different repositories, the sandbox, the staging, and the production one. For all these repositories, we have a very important file that allows us to serve the model using kserve. This is the model.py file that you are visualizing right now. Within the model.py, you see that there are different functions defined that allow us to load the data sets and also the model that we have trained. And what we do is to enable the serving of this model by defining first a predict function that allows us to perform the prediction of the model, and then we will serve them using the kserve, the model serve that is defined in the top bottom of the file. So once we have the model.py elaborated in the GitHub repository, as I said before, users perform a pull request to start the migration first from the sandbox repository, sandbox branch to the staging branch. And once this is approved, they also create a second pull request for migrating from the staging environment to the production environment. This migration is triggered by GitHub Actions. This is what you are seeing now on the screen. So these are the GitHub Actions that completed the migration from the staging environment to production. And once they are completed, as I said before, we have two endpoints available, one for the staging environment and one for the production environment that allow us to perform inferences. So in the screen now, you're seeing an example of an inference that we perform to the crowd density model to get in the crowd density in this Scheveningen Boledig area in The Hague in Netherlands. And this is the result that the model returns when we perform the inference. This is the prediction. And now focusing on the last model, which is the model monitoring. In the Grafana dashboard, we have first some dashboards that show us the metrics that we have collected for the underlying computing infrastructure where the platform is run. So this is the Kubernetes cluster. Mainly here we can see different metrics that allow us to monitor the status and the resource consumption, the computational resources that are consumed by the platform, the RAM usage, and we can see this per namespace, per user. So it allows us to monitor the status of the infrastructure and prevent disruptions. And finally, for monitoring and visualizing the status of the performance of the models, we have created also different dashboards that show as example, for example, the quality of the data that has been used for training the model, also the data drift of the data sets. And finally, also, this is an example, these are not real metrics of the crowd density regression performance of the model. So this you can see also that we are able to retrieve and visualize some specific metrics for the performance of the model. So yeah, this will be all regarding the demonstration in the video. And now I will conclude the presentation, summarizing what we have seen. So first, I presented the platform and the concept together with the architecture. We have tested the platform to deploy the Cloud Density Emerald service in both the staging and the production environments. We showcase the operational behavior of the platform. And finally, we ended by visualizing the data and the model predictions as an example of what the Cloud Density Emerald service would return through the monitoring visualization. And yes, this will be everything on my side. Thank you for your attention.
Thank you very much, Jose. So this is very interesting because we could see actually the implementation of the platform, and also very, very nice to watch the video with you explaining actually what is in it. So now we have another contribution and another very important topic that we want to cover today with Mahmoud Sakhr from ULB. And I leave the floor to him to introduce himself and to present his presentation. We are going to talk about standardization. So his contribution is Emerald's contribution to standardization and advances in standardization for future urban mobility, which is a very important point for us, especially in this phase of the project. So Mahmoud, the floor is yours. Please go ahead. We can see your slides very well. Thank you. Go ahead.
Yeah, thank you, and hello everyone. I am Mahmoud Sakhr. I am Associate Professor in Université Libre de Bruxelles in the Engineering School. And we have been partner in the Emeralds project, mainly doing research, so developing Emeralds, but also active in the standardization aspect, which is a transversal aspect over all the work that has been developed in Emeralds. In the talk today, I will speak about the advances in standardization for future urban mobility. So urban mobility is well established. Services are there for decades, public transport. And there are many applications that are running besides public transport, traffic estimation, ticketing, city planning, even marketing. And around these applications, several modalities of data are generated and consumed and are being shared across the different players in this ecosystem of urban mobility. And in order to enable all the stakeholders in this ecosystem, standards are essential. So we have standards like GTFS, NetX, SERI, DATEX, GBFS for micromobility, and MDS also for micromobility. We have used some of these standards in Emeralds, but also we have had a look to the future landscape, because with the modern mobility services and offerings come new applications. We have autonomous vehicles. We have micro-mobility safety. It's becoming critical for cities. We have new kind of logistics, bike logistics for last mile delivery. So there are new applications that generate different kind of data. So now we need to look at detailed trajectories, not only origin destination. We need to look at temporal properties of trips of the movement. Videos are becoming more and more also part of the data offering and available, and the orientation of the moving object. Accordingly, new standards started appearing in this landscape to meet the requirements for these future requirements. So I'll speak about OGC API of moving features, GeoParquet, GeoPose, WebVMT, but there are even more than this. So starting with existing offering, I'll go quickly over what exists and how this links to the future. So GTFS schedule. GTFS is General Transit Feed Specification. It's a format for public transport schedules, which is originally developed by Google. Basically, it encodes what you see at the stations. Either let it be a bus station or a train station. You see a schedule like this that describes different calendar days and then the schedule of passages of trips. The format itself is a set of CSV files encoded in text and all bundled together in a zip file. We call it GTFS schedule or GTFS static because it represents the planned situation. Real-time extensions that capture the operation is in an extension which I'll show next called GTFS real-time. And this is widely adopted by transit agencies, and we have used it heavily in Emeralds. GTFS real-time then extends on this GTFS static and provides real-time updates about the transit vehicle position and service disruptions, predicted arrival time. So basically, it encodes what you would see at a station. The screen here is for a train station that shows which trains will arrive on time, which trains are delayed, and you get the update from this screen. The very same format encoded into a data format using GTFS real-time. It uses protocol buffer, which is a binary format for compact and efficient communication. Basically, it consists of 3 real-time feeds, trip updates, which is about delays, vehicle positions, about locations, and service alerts to give information for passengers. And then moving from public transport to new modes like micromobility, there are formats like the GBFS, which is General Bike Share Feed Specification. It's a standard for real-time information about the shared micromobility services. It builds on JSON, and it describes the metadata of the system the location of the stations, and the real-time availability of the vehicles. That's probably the most important component. So you know which are the available vehicles, what is the level of charge, if it is electric. So this information is basically what enables third-party apps like Google Maps to integrate real-time micro-mobility. When you open Google Maps, you can it can suggest to you to take micro-mobility bikes based on the information it pulls from the GPFS feeds of the different providers. And this is maintained by Mobili Data, which is a consortium, a worldwide consortium developing some standards around micro-mobility. Even older TMC traffic message channel. And this is an ISO standard for broadcasting real-time traffic and travel information via digital or FM radio. You probably, while driving in some highway, you hear sometimes the radio signal is interrupted and you get some information about congestions and traffic. This is following the TMC standard. It includes traffic events such as accidents, congestions, road closures, and so on. And this is widely integrated into the navigation systems that are built into the automotive autos. Now, in this landscape, there are also European standards. NETEX is one significant such standard. It's about network timetable exchange, developed by, it's a CEN standard. CEN is the European Committee for Standardization, and it is meant to exchange public transport schedules. So basically, analog to the GTFS schedule standard, but it adds some European requirements on top of that, which are multimodal, multi-operator, and cross-border transport system, because for the mobility across countries in Europe, you need to change operator. You need some requirements which are not available in GTFS schedule to allow the integration of the data from multiple providers and to allow the critical aspect of cross-border services. So the NETEX standard focuses a lot on the expressiveness. So it is much more expressive than GTFS, but this comes at the cost of a higher implementation complexity. The different countries need to have different their own profiles of NETEX, and then the implementation is a complex, lengthy process. It's XML based to allow for hierarchical representation of the data and nesting and complex data relationships. And this is mandated under EU ITS directive, which means that all transport companies in Europe will eventually be implementing it. Complementary to NETEX, there is SIRI, which is a service interface for real-time information, also a CEN European standard, and it focuses on the real-time public transport data. So this is analogous to GTFS real-time. So you see there is a trans model, and this is a conceptual data model for public transport data domain, a European one. And implementing trans model, there is NETEX, there is SIRI, and there is OPERA for the railway. SIRI is a web API implementing the SOAP over the HTTP protocol and uses XML format. And it supports fine-grained queries like give me the next arrival at stop X. And this is also mandated by EU as part of the ITS directive. So eventually all companies in Europe will be implementing it. MDS, Mobility Data Specification, is an API standard for operational data from shared micro-mobility services. So this is complementary to the GBFS, which I explained earlier. While GBFS service public trip planning and third-party applications, MDS service cities and regulators for compliance and urban management. It has 3 APIs, an API for the provider, which has a lot of detailed data that the company can collect about the vehicles and the trips. This data gets aggregated and anonymized to provide aggregates to the city. So the city, playing the role of regulator, can have enough data for building policy, but also maintaining the privacy of the end users. And this is maintained by mobility data. I would recommend, or maybe just hint, a really nice document describing the different existing standards, the state of the art in mobility data sharing standards by our colleagues in the Mobility Data Lab European Horizon Europe project. Then from there, what is the future and what are the advances? And here comes the Emerald contributions. So while we have been using the standards, which I discussed earlier in Emeralds, we have also contributed new standards which contribute to the future of urban mobility. So what is it changing? In the modern urban mobility, there are new applications calling for expanding the standardization landscape. We have mobility as a service, shared mobility, and multimodal routing. All these applications require full origin to destination trajectories, not just start and end, in order to model the real user behavior, the mode transfer, and the route reliability. We have applications and requirements for emission modeling, all the Green Deal and the net zero applications. And in order to do this, we need macroscopic and microscopic traffic simulators that would need to consume continuous vehicle trajectories combined with vehicle type and speed profiles in order to calibrate the simulator. Applications on micro-mobility safety, which is now a big concern for cities, also require full trip trajectories of e-scooters and bikes to reveal risky behavior and perform exposure analysis. Maybe even more, we need videos. For example, some pilot would implement head-mounted cameras in order to contrast perceived versus actual risks for the riders who use these electric scooters and bikes. Autonomous vehicles, a lot of multimodal and massive data streams that are required for the car to operate autonomously. So these applications then call for expanding the standardization landscape. And one organization which the Emeralds partner we're active with is OGC, Open Geospatial Consortium. And in Open Geospatial Consortium, we work in very many directions for standards. I here list the relevant ones: the Moving Feature SWIG, which is a standardization working group I co-chair. GeoParquet, which our partner Carto is active in. GeoPose, SWIG, SensorThings, Web, VMT, and a new SWIG, which is currently under construction in public comment for deep learning models. And while we have direct participation in the first two, we interact a lot with the other SWIGs. So I describe the OGC API for moving features. This is a standard that we released last year, and it represents, encodes, and serves time-varying geospatial geospatial data, such as vehicle trajectories, speed profiles, weather fronts, as dynamic moving features. So for all these applications that require full trajectory data and temporal properties of them, this OGC API for moving feature is designed for that. It extends the OGC API features by adding support for temporal geometries and temporal properties. And the data is exchanged via RESTful interface. So the This is what the main concept of OGC API. It's an API rather than file download. Second standard is the GeoParquet, which also appeared recently and has been a collaboration between several big companies, including Cartos, a partner in Emeralds. And it provides columnar storage format that extends Apache Parquet to efficiently store and query geospatial vector data. Parquet is famous for the compression, which enables high-performance analytics, and this is a feature maintained in the GeoParquet. The geometry is encoded as well-known binary in a dedicated column with sufficient metadata for the geometry column name encoding the CRS, which ensures then interoperability. And this is getting increasingly adopted by the main geospatial libraries and data pipelines, including DuckDB, Dask, GeoPandas, and Carto. So by this, I summarize again what we have seen in this presentation. The current landscape of standards still used and still useful, and we have used it in Emeralds, but is not anymore enough for the future. And when I say future, please be aware that it's a bit tricky, the meaning of future in the world of standardization. We don't design standards for the future. We have to wait for the applications to appear, and that a need for standardization becomes evident in order to be able to define a standard that enables these applications. So these applications and data and standards are there and happening. They are not yet to be invented, but standards are lagging a bit behind, which is natural and needed. So we need first to develop a mature understanding of what applications and what data in order to design useful standards for that. So while it is said here to be future, it means that these standards will enable better implementation of these applications and better exchange of the existing data in the future. And by this, I conclude my presentation. Thank you.
Thank you very much, Mahmoud, for your presentation. Very, very interesting. Also, the recap at the end, the summary of your presentation, very important to understand well and better how the standards can integrate with the application. And on these regards, actually, we have one questions from our audience. So maybe we can start from this point, if you agree, because it's a kind of questions that is very much related, as per my understanding, to the topic that you introduced during your presentation. So the question is, were there moments where standardization requirements conflicted with real-world implementation needs? And this probably matches with what you already said, based on the fact that the application comes first and then the standardization applied to the application, the actual application.
Yes, you answered it, Maria Letizia. So it's by design, this shouldn't happen. If it happens, there is a problem in the work of the standardization working groups. So we need to have the data and applications available, understand them very deeply. Developing a standard is a process that typically takes 2 years, if not more. In all this, we bring speakers. So I have presented Emeralds in several technical committee meetings in OGC until we have built, and we also saw other projects. We invited companies in the SWIG meetings. We meet every 3 months. All that to build a good comprehension of what data, what applications, what are the needs in order to make a standard which is useful, which meets this. Otherwise, it's going to be obsolete. Another thing which OGC has adopted recently, and I think other standardization bodies also do it, when a standard is published, it is first published under a draft status. Even that it has already passed public comment and all cycles of review, it remains draft until it has certain number of real implementations in the form of big systems, companies implementing it. In OGC, we set a number of 3. So we need 3 real implementations of the standard in order to mature the standard from the draft status into a final status.
Great. Thank you. Thank you very much, Mahmoud. Very clear. I think your contribution is very important for the standardization and the wider vision that we have in the Emeralds project. So thank you again. Yeah, I have another question. Probably this question is more like for Yanis. Is a questions related, I mean, more general, I think, but obvious is talking about the research output. So I pose to you, but in case anyone else wants to also reply, is fine. So Yanis, the question is, what do you think is more needed in terms of practical adjustments or support to bridge the gap between the research output and their operational reality?
Yeah, thank you, Maria Letizia. Actually, it is a very old, let's say, discussion when research comes to be a practice, and what is the delay on this. And by the way, it is very important that the EU has all this funding and the grants actually trying to bridge this this gap. And actually, we are obliged to use this word, not to be pure researchers or pure practitioners. There should be a blend, as I said in the beginning, where we are all together, and we also have stakeholders like municipalities, for instance, in our case. Well, I would say the most important challenge is how to break, how to call it, the force of habit. People are used to do their routine, so they are not, by definition, let's say, they are not very likely adopt things that they are not used to have them in their everyday routine. Mahmoud talked about videos or let's say wearable equipment. This might be very challenging, very interesting in terms of research, but it may have several, let's say, obstacles from the society or even from the stakeholders. So it is it should be clear that research done, and I will talk especially about this project. This project will be very clearly communicated with municipalities in our case, where all the use cases have already done it through, let's say, seminars, and industry and decision makers, and we'll adopt some of the things that we have already done. When we talk about the mobility AI as a service platform, we may be heading to industries or organizations that are working with analytics on the field. But for instance, when we talk about better processing of this GTFS data, that we have them in our mobile phones, when we have a list of the timetables of the buses or the metro lines, then it is more important that all our research done in the field, forecasting, more accurate, let's say, estimations of the travel of arrival times. Things like this go very quickly into, let's say, the everyday use. But in this case, this also has to do with the standardizations that Mahmoud discussed earlier. Although I feel that if I can, let's say, jump into his field, I feel that sometimes things are going faster than standards. So we do not have standards, but we all use something. And later comes the standard. So this we have to find this space. And I feel that our pilots, our use cases, this has not only to do with the emeralds, but all these projects are, let's say, our ambassadors in these areas, in these fields, and therefore we should have a very tight, let's say, collaboration with the use cases. Not only take their needs and try to address them, but also help them improve, extend their needs. Therefore, we also talk about exploitation goals and scenarios and all these things. More or less, this is my answer. You are working also on the exploitation part. Konstantinos, our project coordinator, is also here, and he could jump in if he wishes. So, for the moment, this is my answer. Thank you.
Great, thank you, Yannis. Anyone else who wants to add something on this topic, which is, I understand that it's quite broad, but it's always interesting anyway.
Yes. Okay. Hi, Maria Eldica. Hi, everyone.
Hi.
Yes, I agree with Yannis. Actually, in parallel with the technical achievements, let's say, Emeralds placed strong emphasis on exploitation and the transfer of their results, from research to practice, at least where this was possible for some of the research outcomes. The project initially identified and prioritized the key exploitable results, supporting, their maturity level through the pilot validation. So it was until the last period of the project where we had the chance to identify and assess the maturity of these results. By fostering mainly the collaboration between RTOs, research organizations, academia, industry partners, and city stakeholders, because we actually ran 3 use case workshops with stakeholders participating from Netherlands and Riga. We're able to create, clear pathways for further development and also integration, I would say, into existing platforms. For example, Carto and Atos. Jose here presented the main advantages of Atos platform. Last, this research industry alignment that we are able to materialize through this kind of projects ensures that the project's outcomes extend beyond the research phase. And of course, for me, it's very, very important to highlight that we ensure the sustainability of the results, and so we ensure that the results are reusable for other projects too.
Thank you, Konstantinos. Yes, the exploitation part, and obviously, the let's say the evidence of our work done and the legacy that we leave behind is important to go ahead and to talk about future, about present, about also future. And related to this point, I actually have one question that I think is perfect for Jose, because it's talking about the platform that you presented, Jose. So I don't know if you have some points on this, but the question is, says that regarding the platform as a service, long-term sustainability beyond the project life cycle, what are the main technical and organization barriers you foreseen in ensuring cities continue to use and maintain the platform? So use or continue to use and maintain the platform.
Yes, I think I can answer this. So from our side, it's important to take into account that the main objective of the platform is to manage the life cycle and automate the deployment, the serving, and the monitoring of existing machine learning models. So for this, it's very important that if any new cities want to use the platform, or if the current cities that we have in Emerald project want to still use the platform, it's important they keep having data sets and the data available for training these machine learning models, and that also they have either the manpower or the resources to build their own machine learning models, or to outsource the design and training of these machine learning models to any third party that is part of the municipality ecosystem. So to be very direct, my answer would be that they need to have the data available. This is the most important part, because everything begins there. And once the data is available, they need to be able to design and train the machine learning models to onboard them in our platform, so we can manage the life cycle of these models, train them, deploy them, set up them, and also monitor the performance of this model. Yeah, so this would be my answer.
Yeah, very clear. Yeah.
Yes, I would say, Jose, that probably next step right now is how let's say partners that provide a platform as a service solutions will be able to efficiently integrate the LLMs models in order to increase let's say the automation phase for the clients. This is something that we could not predict when we started the project, but here we are, and maybe it's the next step for another project.
Indeed. This is something that is part of our roadmap that we are currently exploring, and that we would like to keep exploring, is the introduction of the LLM ops capabilities instead of only exploiting the MLOps, as we have been doing in the MLOps project.
Great. Thank you.
It would be very interesting to see in the future how we could leverage the advancements of these emeralds by integration of LLM models to increase their automation phase. But okay, yeah. Of course, this project concludes in 2 weeks, but I'm sure that we're able to collaborate in some future initiatives.
Yeah, and talking of which, I want to give some final recommendation to our audience, if I may, because as you said, we are closing in 2 weeks' time our life cycle, let's say, of the project. But we have a very good and important document online where we put together many of our results, and we also include them. There are some recommendations that are oriented to policy adoption, let's say, vision. So it's very important that everyone can contribute. I added in the chat the link to the open consultation that we have open still there, and will be along the next weeks and months. So every contribution from everyone and every stakeholder is very much, let's say, welcome. We also have the actual document that is uploaded on Zenodo that you can download and you can read and use for your comments and for your feedback. We are very glad to have all your comments on this and on everything else. So now the time is closing. So
I have provided the link to the chat. Okay, yeah.
Yeah, thank you very much. Yeah, the direct link is on Zenodo, so good that you can take the document there directly and download it. I want to thank everyone for this last webinar, the audience and all the speakers, and thank you for your time today. I think that was a very interesting and very nice webinar today, because we talked about results, we talked about final recommendation, we talked about what is next. So it's important for us and for everyone in the field. So I want to wish you a very, very good holiday break also to everyone, and thank you again. Bye.
Thank you.
Everyone.
Bye, bye all. Bye. Bye.